Hi, welcome back to Engineering Mechanics Dynamics, and I'm Dane Quinn from the University of Akron, and today I would like to do an example problem dealing with Cartesian motion. So here it is. We have a particle P that moves along a parabolic path given as this dashed line by the function y is a minus cx squared, and then x is given as a function of time, so that x is equal to v times t. So note that y is given as a function of x, and then x is given as a function of time. So we'd like to find the velocity and acceleration of this particle. So in order to do so, we have to first describe the position of the particle. So given p, let's identify the origin, O, and then write the position vector as r of p with respect to O. And of course this is a function of time as the particle moves along the path. So then let's go through and define the directions I and j. So I is horizontal and j is vertical. As a result, the position vector p with respect to O can be written as x of t in the I direction plus y of t in the j direction. So we'll use the coordinates x and y to describe the position. And then along this path, y is given as a function of x. So the position is x in the I direction plus a minus c x squared in the j direction. And finally, making use of the fact that x is given as a function of time, this position vector can be written as v times t in the I direction plus a minus c vt squared in the j direction. So now we're looking for velocity and acceleration. Velocity is simply the derivative of position, right? So we'll look at the position vector and evaluate the change. So the velocity as a function of time, derivative of this as a function of time. So we have v in the I direction because v is the derivative of v times t. And then in the j direction, we'll make use of the chain rule and write this as minus 2c times v times t, and then the derivative of what's inside with respect to t, that's another v in the j direction. So we can combine this a little bit and write the velocity as v in the I direction, and then in the j direction minus 2c v squared times t in the j direction. Looking at the acceleration, well, the acceleration is just the derivative of the velocity. So we'll do that whole procedure again and find that the acceleration of p as a function of time, well, in the I direction we have 0 because the velocity in the I direction is 0. And then in the j direction we have minus 2c v squared. And there we go. Given the particle and the path and the motion in the horizontal direction, we describe the position. We evaluate the change in the position to get the velocity, namely take a derivative. And then we do that again. We evaluate the change in velocity to get the acceleration. So that's it. Thanks.